When your school is through a computer screen, go to Science Corner with Constantine.
Hello and welcome to another episode of Science Corner with Constantine. Constantine is me, as you well know. I'm here in my childhood home, and also more specifically, my childhood kitchen, to show you a lab that we would have done in school, but unfortunately cannot do in school, and therefore I will do here. The topic of today's lab is the speed of light, aka how fast light travels. So light travels ridiculously fast, but just how fast it travels I can show you using a measuring tape or a ruler, a microwave safe plate, a microwave like the one in my parents' kitchen behind me, and something that will melt, cook, or burn. I decided to use a bar of chocolate because that's what I have access to. You can also use some sort of light colored bread and put some margarine on top or butter on top. That will cook nicely. You can also use a marshmallow. That will melt down and burn very nicely. So those are some options to do this lab. Follow along with your lab packet that's on Google Classroom, and after you watch this video and fill out the packet, try this lab on your own with adult supervision. So how could I possibly figure out the speed of light using microwave safe plate, chocolate, a ruler, and a microwave? Well, to understand the answer to that question, we're going to learn a little bit more about how microwaves work. If you refer to this expertly done drawing of a microwave, you see that microwaves use actual microwaves, which is electromagnetic radiation, to heat your food. The microwave will shoot a wave across the microwave oven and it'll bounce back, and that electromagnetic radiation increases the energy in your food to warm it up. Usually microwaves have a plate at the bottom that spins, but if you take that plate out, you'll notice that the microwave has hot spots and cool spots. So there will be places where the wave will actually hit and places where it won't. The places where it does hit will become the hot spots in your food. In order to find the speed of light, or in order to find the speed of electromagnetic radiation, we can use this equation, which is speed of light equals wavelength times frequency. The frequency we find by actually looking at the microwave itself. Microwave frequency is something that manufacturers will put on their stickers inside of microwaves. But the wavelength is what we want to find out using our chocolate. So, if this all goes according to plan, we'll be able to measure half of the wavelength by measuring the spots that are melted in our chocolate bar. Then we can multiply it by the frequency found on the sticker inside of the microwave, and that should tell us the speed of light. So, in order to start this lab, let's see what the frequency is of my parents' microwave. So to figure out the frequency, we can usually go to the microwave and look at a sticker on the inside. Yours would probably be somewhere around here. And mine doesn't say it. That's what I get for using a microwave older than I am. Due to the fact that this microwave is over 20 years old, there's no sticker that says the frequency. But luckily, I happen to know that most microwaves, even microwaves manufactured in the 1980s, have a frequency of 2,450 megahertz. So because megahertz is millions of hertz, that actually means that the frequency is 2,450,000,000 hertz. And that's the frequency value that we're going to use for our equation. But in order to find the wavelength of the waves in our microwave, to figure out the other half of the equation, we are going to use this chocolate and this microwave safe plate. So, as you know, microwaves have a little spinny plate inside. That's why it's so fun to look inside one. So that spin in the plate is what keeps your food from getting these hot spots and cold spots because it spins it all around. But I don't want that. I want the hot spots and cold spots so I can measure the distance between them to figure out my wavelength. I'm going to place the chocolate on the plate in a line. So the chocolate I'm using is already kind of broken up into little pieces. So I'm just going to piece them together as if I was working with a big chocolate bar. Now I'm going to put it in the microwave until it starts to melt. I think this is going to take about 30 seconds. Let's see. Did it work? Ooh, whoa. So it definitely worked. So it looks like, in this particular sample, I'll bring it up so it's closer. I've got a hot spot right here where it's melted. It's melted right here. Oh, it's falling. Oh no, there's chocolate everywhere. And it's melted over here on the end. Over there. So it's like one is here and one is there. And one's on the floor. So in order to figure out the wavelength or where the microwaves hit the chocolate, this point and this point, I gotta measure it. And remember, in science, when we measure stuff, we use the metric system. So I'm gonna measure it in centimeters. This tape measure doesn't have centimeters. And neither does this one. Alright, so now I've got a ruler that has centimeters, and I'm gonna measure the distance between the two hot spots on my chocolate. Looks like I have a distance of 6 centimeters. If you look at this diagram again, half of the wavelength is represented by the two hot spots. So half of my wavelength is 6 centimeters. The full wavelength is 12 centimeters. So in order to figure out the speed of light, you multiply the wavelength times the frequency. I would like to know the speed of light in meters per second. So I'm going to change my centimeters to meters, which would be 0.12 meters times my frequency, which was 2,450,000,000 hertz. I can multiply them together with a calculator and get 294 million meters per second. 294 million meters per second. I converted my centimeters to meters to get 0.12. I multiplied it by the frequency in hertz, ended up as 294 million. Let's see what the actual speed of light is to compare it. So it turns out the actual speed of light is 299,792,458 meters per second. I'm not that far off. Considering I was using chocolate and a microwave from the 1980s, I didn't do half bad. We can calculate my percent error, and I got a 1.93% error, which really isn't that bad at all. For the sake of this lab, let's say that the real speed of light is 300 million meters per second. That'll give you a pretty good place to reference whether or not you got it pretty close or not so close. Overall, I'd say that wasn't that hard to do. I didn't burn the house down, and I think with adequate adult supervision, that's something you could do at home. Try this for yourself, see how you do, email me your results. Remember to fill out the lab packet on Google Classroom so that way you can follow it step by step and really know what you're doing. So, all in all, looks like we can figure out the speed of light with chocolate, a ruler, and an ancient microwave.
Science Corner with Constantine.
With adult supervision.